All right, so welcome to Monday. We're going to first find the greatest common factor, and we're going to start out by finding the list of factors using factor trees. Then we're going to stack them on top of each other, and then use that to find the greatest common factor that way. Okay, so first let's use our factor trees over here. 30 is equal to 3 times 10. And 10 can be broken down into 2 times 5. And now I'm going to circle all of my prime factors. 45 can be, that's actually 5 times 9. And then 9 can be broken down into 3 times 3. So once again, you're going to circle your prime factors. Okay? All right. Now what we're going to do is we're going to list those factors from least to greatest. So first we're going to start out with 30. That's 2 times 3 gives me 6. And then 6 times 5 is going to give me 30. So smallest to biggest. Now for 45, we have 3 times 3 times 5. And last but not least, we are going to find the common factors and multiply them together to get the greatest common factor. 2 and 3 are not in common, so we can't do anything there. So now we're going to see that 3 and 3 are the same. So we're going to circle those, bring it on down. Multiplication, bring it on down. Next one, you have 5 and a 5. So I'm going to bring that down. 3 times 5 is going to give me my greatest common factor, 15. So the GCF is equal to 15. Next, if you want to simplify fractions, you have to divide the numerator and the denominator by the GCF. And remember, whatever you do to the top, you have to do the bottom. I know 15 is the greatest factor that can go into both 30 and 15, so we're going to divide by 15. Now 30 divided by 15 is 2, and 45 divided by 15 is 3. So 30 over 45 is the same thing as 2/3 simplified. Okay, I said that wrong. 2/3 is simplified from 30 over 45. Okay, now last but not least, we're going to look at adding unlike fractions. Okay, first off, you're going to look at these guys and you're going to realize 3 and 2, those are not the same, so it makes those fractions unlike each other. Okay, so the way that we handle that is we're going to multiply the fraction 2/3 by 5 over 5, because that's 1 whole, and anything multiplied by 1 does not change in value. And on the other side, we're going to multiply it by 3 over 3. Okay, so let's do this. 5 times 2 is 10, and 5 times 3 is 15. Okay? Bring down the subtraction sign. Now we're going to go 1 times 3 is 3. 1 times 3 is 3, and then 5 times 3 is 15. Okay. Now we have like fractions, 15 and 15. So when you have like fractions and you add or subtract them, the denominator stays the same. So we're going to keep it 15. And 10 subtract 3 equals 7. Okay, so the table shows the daily low temperatures for Cleveland, Ohio over 5 days, and they want to know which expression can be used to find the average daily low temperature during the 5 days. When you find the average, you have to add all of the numbers together, and then you're going to divide by the amount of numbers that were added. All right, so if you look at your options, we have pretty much the same numbers. But we have to be really, really careful, because when you look in the table, we have a positive 15, and we have a negative 2. But in option A, you can see that you're adding a positive 2 right there. And so A is automatically not the right choice. If you look at B, it's a similar thing, okay? Like, we don't have the negative 2. It's still positive, so that's wrong. You can get rid of that. Now the question becomes, is it C or is it D? Because all of the numbers appear to be the same. Positive 15, negative 2, and so on and so forth. So here's the thing. The order of operations PEMDAS tells us that we have to do division before we do addition. And when you find the average, you have to add together first and then divide. So the way that you would be able to do that is by putting a set of parentheses around the numbers you're adding, and that would allow you to add first. And so option C is what does it. So the correct option is option C. And you can see that the person who did this one chose option D. And I took this screenshot off of the benchmark, so they got that one wrong. Anyway, the correct choice is option C. Oh yeah, there's 5 numbers, so we're dividing by 5. And now let's look at question 2A. The highest point in a state park is 145 feet above sea level. So I'm just going to underline that, and it's above sea level, so we know it's going to be a positive 145 that we're working with. The lowest point is 28 feet below sea level, so we'll highlight that, and that's going to be negative 28. Okay, and now they want to know what is the difference in elevations, and when they say difference, they're asking us to subtract. So we have 145, and we're going to subtract a negative 28. Now this is the neighbor rule. You have neighbors when there are 2 signs and there's no numbers in between them, like what we see below. And so a double negative using neighbors is actually going to be a positive. So it's actually 145 plus 28, and that's equal to 173. If you don't like adding horizontally, you can stack it up on top of each other and you should get the same thing. There we go. All right, we're going to practice another one just for good measure. The highest point in another state park is 162 feet above sea level. The lowest point is 13 feet below sea level, and so they want to know the difference again. So it's going to be exactly the same setup. You have 162. You're going to subtract a negative 13 because, again, when you find the difference, that is subtraction. But if you're below sea level, then that's a negative number. So that gives us our double negative again. And 162 minus a negative 13 is 175. So the difference in the feet is 175 feet for both of those. And we're done.